say, Dimitri, can you change the dimensions of your box by going into VI instead of doing the tint to VASP?
Then you need to re-optimize, because if you expand size of the box, it will automatically expand proportionally all point distances.
Oh, that's right. Yeah.
Which is not a big deal. I'm okay with this.
Well, I realize because the way my box is oriented, it's just going to make copies instead of elongate it. So
You could always just steal Dimitri's.
I could,
Which you are welcome to do.
but it worked. So
At no time you will do, each of you will do individual projects, so there will be less chance to borrow from me or from each other, even if you had such
yeah.
thought. Good. Sometimes with grep commands, you get all zeros.
I was just doing it step by step.
Did it work? Well,
Just checking the
worked.
So this
So,
one for screening.
The way mine's drawn.
How many steps would you
It doesn't just,
in no first or
Mine's drawn. So
They have two sections.
I don't
in
think
file,
this
right?
worked because he said that this is your energy, and this is not energy, it's zero. So I don't think mine worked.
What about the sixth column? Sixth column is
So I'm
not.
propagating along this axis.
My sixth column is waves.
I have to propagate it along
No,
the
no, they have two
y-axis if
sections.
I want to get the polymer.
Change your K points.
I
Mine
You
goes
get your
zero.
rotate.
I have to do it in the XYZ
Last
file
column?
and rotate
This is
it.
on zero.
And I'll make a separate
When
file.
I-
And that's weird. Yeah.
How do you
Run them both.
When I do that, I get
Manually, like
I don't know,
right
I got what he got.
zero.
right click?
Yeah.
That's
For
because
some reason,
En- energy
does.
wise.
You made
I want to
I don't mind.
space is more making difference.
mine's still going.
Because no, you see these two
But
sections.
maybe as this is going, I can do another one.
These have more space. So if I put the more space, it will grab this. We want this number, not this.
I thought Dimitri said that this is our energies. Here, because if we do 1, 2, 3, 4, 5,
6 is where?
6 would be this second decimal. The third decimal. But I don't know if I did it wrong or.
Okay.
Yes. So
You see?
that number has to be the number.
Yep.
0.7. Okay.
So we do positions. And it may go through the list 2 times. Just 4 points. The rest should be easier. Now you have 4 of those.
So if we expand from the x, this
Apparently,
Right.
this number has to be the number of
Just
K
copy
points.
from the out of the other.
That's the only difference.
And do not run, just go immediately to the position files.
For the K point line, the star money sign. Yeah, so that's the number for K
So
point.
instead of only having 1 unit cell or 4, we're gonna have 16.
okay, so 16
Or
change it.
how many does it? So you did. So your K point file has 8. Then how many does?
Around
Like
the-
an
My K
output.
pointer has 16, but my
So only
output
key points
only has
change
8.
it.
Oh, and then your in-car file.
And
Just
the
like
8 didn't
you
work
have.
either.
Because the money assigned begins to the eighth column.
NSW, so it says one.
So when you
right now.
say 6,
You change to 0.
Oh.
that says
Just
to the
the
sixth
other
column.
one.
So there's just not gonna be.
So if I get rid of the awk command,
Oh.
No,
this is
no,
what
no,
I
no,
have.
Okay.
on that.
I first it. Secondly, in your.
When I add the awk, it says
Yeah, but
Yeah.
print
you do
the
the
sixth
copy to
column,
your
that's
Yeah,
what money
now
assigned.
I
And since several
So
people
1,
were trying to
2,
do
3,
something
4,
there, it can be already
5,
a little
6, 8. 1, 2, 3, 4, 5. No, 1, 2, 3, 4, 5, 6. All zeros.
Well, maybe you can just put in 4.
excellent.
Those look like your K points, so maybe it's the 4th
Now
column
I'm
then?
running this commands line by
And
line.
if
Okay,
you do
okay.
4, then it's gonna get us
It's still two different columns, but
Weird.
they have no space. That's why it look like one
Yeah.
one column. Yeah.
So it's gonna, so that's why I think my calculation went wrong. Because when he went through his out part, he said that these were the energies. And I have all zeros. So I'm assuming that there are 3 columns here that all converge to 1 because of the zeros. Does that make sense? Because then this would be my 6th column, and this would be my 6th column, and these, if these weren't all zeros, then it would have some energy.
So I change the 16 because.
Yes. Everything is very good.
I don't know, check your, I don't know, so go to the out card and see what the actual K points are, or K values are.
Oh boy.
Just check.
Yeah, I had the same thing that happened to you with the first column, printing out the extra zeros. But the first digits though, those are, I know those are my K point values, cause I did this earlier. I
Oh,
went
so the
through my-
first line's the K point values?
Yeah, so those first digits are, and then it looks like you just printed them twice.
Was it constant?
I don't know. Oh, see, Dimitri, this is his are, if we would assume that these are supposed to be 3 different columns, then this would be the 6th column for him. So that's why I think something went wrong with my calculation or something. Oh, this is in the Z direction, so ours is in the X direction, so
Oh,
that would be the
X, Y,
first,
Z,
so it would be the first column.
so that's what it's for.
But it's really weird, because if you did 4 or 5, if you do anything but 4, you wouldn't get this like energies. So then how do you determine if this, like if you had an energy here, like a, yeah, it's weird, I don't like that.
I think for,
Because if you made a quantum wow, like a sheet, then you would have K points in both X and Y or 2 directions, so then you would have like overlap, which is weird.
Quick question. I'm copying a file with Dimitri's. How do you copy it? So I've only copied stuff like that one directory.
You put a period, so you say CP, you write the path
The entire path? Like, so I
to
can't do 20.
his directory.
So I started my own directory.
Yeah, so like if I wanted to copy this, so this is his file, right? So if I wanted to copy that, I would say CP, the directory. I could also go backwards, so I could do 1 dot dot dash, 2 dot dot dash, 3 dot dot dash, 4 dot dot dash, Dimitri, and then go into his file.
Four dot dots.
So dot dot dash
Yeah.
means go up a directory.
Okay.
A
So you tell me.
period means this directory. So like is I'd go up 1, 2, 3, 4, so I would have 4 dot dot dash, like 1, 2, 3, 4.
I gotcha.
Or I can say, okay, I'm gonna start from root directory and go forward, so you can do it either way.
So, okay, that makes more sense. I was wondering how to go back, so the number of dot dot dashes is how far you back.
Yeah.
You just need to know one.
Yeah, if I wanna go forward, I just use it.
No,
Yeah, it
if
did.
you wanna go forward, you just type the path.
We can just paste it.
Thank you.
Okay, so if I'm in my own directory,
Now Control C.
I type his like CHEM476.
Yeah, so like if I copied this, I would do, so,
And this is gonna go to your,
This line.
Yeah.
directory right now.
so, just like SCP, you say where the file is, where the file is going.
Yep.
So this is where the file is, this is where the file is going. If I wanted to put in a subdirectory,
Oh, yeah, extract.
then I do the subdirectory and the name. So then I can do more, new, test this out, and now I have this
So
file.
if we need
Does that make sense?
They do that one more time for me. I'm stalling.
Okay, so let's say I wanna go back 2 directories. And now I do make copy. Copy, right? So I made a new directory. And I said copy. So CHEM476, 2006, Dimitri.
I want to
Z out, right? So the command where the file is. Now where do I want to go? So I made a new directory copy. So I put it in there, and now if I do ls copy, I have the file.
Okay.
So, but if let's say I didn't want to put it in copy, I wanted to put it in this directory, then I can go back. Right?
Okay.
But you cannot say this. You cannot say copy the file.
Yeah, it's because you don't have words going on.
Yeah, you don't have a list.
In the outcome one, how do you get this file? Outcome one?
That's just how he named it. I'm assuming you just copied it.
But it's running the same history.
I don't,
But yeah, I'm getting, from the outcome, I'm getting the energy. Yeah, this one.
I don't know.
try this. How do you get the kick?
So Aaron, do you know if
We need to
the
change
energy of the K point the momentum can be greater than 1?
No.
No? Okay. That helps. Okay.
So I'm just trying, cause if it's based off percent, if it's a percent,
Then it would be
then
greater
one,
than the unit cell.
yeah, and there's no need to go outside the unit cell, so I guess
And
that's probably why.
if you were going outside the unit cell,
Your
your
system
velocities
is
would
more
be
than 9
quite
volts,
large.
so you need to.
And then VAST, I don't think can handle it because most of
everything
the
is
codes
the
are
same
not
thing
related
as
to
everyone,
instant,
but everyone does C4H, C2H2.
which you would have to have if you're
I
going
have 16 over
fractions of the
Too
speed of
good
light.
for training. If you do
Well,
research, then
For
some
accurate
additional corrections.
predictions anyway,
No,
you could probably still do it, it just,
Not be so well.
On the way back. Will you check the files
I have
and
done the-
not zero.
Last
so does anyone
Look
figure
inside
out the
more K9.
second line? or how to call
Yeah,
it,
so I guess can
Yeah, I
just
have opened out.
good energies of the orbital.
Good.
Yes.
Yeah, 7.
That is good.
Are you
Bunch
done?
of junk.
No, because it took me a while to figure out what we wanted from this. So we just want
You
this.
just want this figure.
I obviously. But where we pull it out, because since they're all together.
So delete this.
Wait, we want the energies?
Go to the 20.
I'll let you do yours.
Then. Run each and every number. Each and every. Yeah, each and every.
So we need first code. Well, 1, 2, 3,
Oh, so
4.
we want this, not this energy.
It will need any information from the
Oh,
outlet
okay.
output file. So it will extract some information. This command will
Okay.
extract. Oh, so it will automatically extract. So first time to write.
It's not energies, this values of K.
Okay, so these are the energies.
This parsing command is not ideal. You can design it such that it will extract only those.
Okay, but this is what we want.
Yes.
Okay.
Okay. Just in case something gets corrupt.
You automatically get those. The writing that over right. Yeah. Okay. Then you can go to one line. So
You know, you can just do it all at the end, and then the last one would be.
let's go.
Okay. Let's do run the C2HD.
I thought we were doing. Oh, sorry.
Let's do the same exercise for everyone so that we do not spend too much
All
time.
the other lines.
And improvement in your
Oh.
C4 H4. Number of orbitals doubles. Therefore, if you count for 10 orbitals, then only the lower half of the
Okay.
That's
That,
right now we
I'll look at the script and I'll copy it and
and
bring it.
if you have time you can make it generic so that it will be just running in cycles.
Can you take me out from this?
Merge together.
So where's the L1? Alcohol 1 come from? Oh, so.
I changed it to
It shows that no such file will read to
just this one and look for I anticipated
Thank you.
One hit along the y-axis. My box is way too big and I can't shrink it. So if I do this minus to justify that much.
Do this one? Or are we still waiting?
Yeah, or attempt to do it.
That's just the script.
But what number, what was in here?
Oh, you just leave a space.
Is this space? But it doesn't work.
You can just type in
Somewhere else.
tilde
So you
slash bin
can-
slash.
You
right.
you have a stock file
And then copy this one.
with the
right.
value. in it.
No, that's
I'm an
in the
idiot.
script.
And
So
you're
you just
going plus or
run.
minus
Yeah,
from that stock number.
yeah. So what I should be doing is to figure out what the stock is. Oh.
I just don't put the
Like
more.
if you, yeah,
You
if
add
you
one
just
to it.
type in
Right, so I should
that,
to that minus 2 to that will be P6.
after making the
Oh, okay,
KK,
just type in that one.
then that
Okay.
runs it.
Make what?
Holy
what
shit.
KK?
The
Oh, okay.
Jeez.
It's almost like, you know, I listen.
You take.
I'm not a very smart man. Oh boy.
You are doing that in a separate one, right?
Yes.
So
yes.
it's not gonna
Yep.
work, right?
Yep.
Wrong.
Okay. I have solved my own problems. Okay. Let's go ahead and remove this.
Insert. Like this. Just copy paste this.
Oh,
you have to have directory. So it looks like, oh,
Don't worry,
so unless so if you don't start at the root directory, you have to have this.
So
So if you do copy, if you do just like this, it will read in this directory. Right? So you have to tell it where to start, and by default, it's within the directory.
Okay.
and this does what? It tells it to go to the very beginning.
So the tilde, that means go to my home directory.
PDF file and see how it looks like.
okay.
Maybe
And since
okay.
in this cluster, the home directory is also the working directory,
Good.
Yes.
it's fine.
Figured out my problem.
I still have
So
no
like,
idea with all
if you
this.
work
Okay,
with CCAD, your home directory, you are very limited to space,
From the class.
like gigabytes of space. Where sometimes a calculation might need tens or hundreds of gigabytes to be able to run. So here they have a thing called Scratch instead of home, so that is why it's very important to know where you're copying stuff. And if you do backslash, that means start at the left directory. So if you can you do PWD?
Just now?
So what does it say? Home, clean
So-
clean lab,
If I started here from the very beginning, instead of doing the tilde, that would work.
yes,
So this tilde slash starts me, gives me all this information.
yeah.
So can I do a tilde slash and start at same? Or does that?
No.
Just I can't.
Because how the cluster's set up is we're all on one account. And there's only one home directory.
And that's the CHEM476.
No, that's clean lab.
Oh, I see. That's the home directory, so I do tilde, start from there.
And then you go to chem whatever.
I
Right?
see. Yep.
So if you don't have a forward slash in front of anything, it means start at my directory and go.
Okay.
If you have the tilde slash, that means start at
What are
home,
key points?
clean lab,
Velocity, average
And then
velocity with which
whatever.
all electrons
and
move
if you
at
have
once.
Okay.
just the forward slash,
Yeah.
that
If
means
there
start
are
at root,
others-
and then I'm gonna tell you exactly where to
If it
go.
is periodic,
But
then it is
The,
same
the
pattern.
lowest,
Again,
the, like,
so that'd
if
be
you think
home.
about,
With a conjugated
No.
polymer,
no, home is your home directory,
infinite with
Right.
universe.
has home in
The
it.
replicas going with different velocities.
So just type CD,
Um,
now do PWD. What do you see?
download this file and put it in PDF.
Sorry, CD goes
Bring this one
home.
to your
So if
Okay,
we
so
go
that's
here,
You
the
don't have
copy.
it?
now if we do CD, it tells us
So we
forward
go
slash, so
to
that means you're in the root.
where we are, chemistry,
Okay.
this one.
So
So the
Then
next
just
one, if I want
find
to
this
move it forward, would
directory,
be.
double click.
So like if you think about like a family tree, right? You have your maker, mate,
Oh,
and then you
It's not pulling
vert is
out the
There's
There's
energies.
no name for that, it's just the backward slash type of thing.
that's
the root.
yeah.
Okay.
So if you watch
It's because you're doing
person
different-
of interest, do you want? There's a person on there called Vert, and she's a hacker. And another thing,
No, I didn't save this K1, but I ran it.
if you are a Vert, that means
Just to see what it
you are
output
the system
before saving
admin,
it.
and you can do whatever you want on the system. Even if the people have password protected stuff, you can just. So you don't wanna make the Vert mad at all, ever, never.
Who's the other thing?
I don't know.
No?
No, Dimitri's not the Vert. He's a user, not an admin.
So the root's the same guy
It's a
that
big pain to be an admin.
Yeah, it is a,
You want to
you,
get as much privileges of admin, but as
Yeah.
less responsibilities of admin.
right,
Okay.
but I would trust Dimitri as an admin.
No.
No,
People were suffering for the whole University of Washington when I was doing this job.
oh, you were, Oleg was paying you as a postdoc and you were being the admin?
He was, we are on the record. He was saving money, and he was not paying for me. He made someone else to pay.
Oh, okay. That's logical then. Because that it's a pain.
I would not like to be an admin.
No. Gosh, no.
Because if something goes wrong, you're
Oh yeah.
fix it.
Okay.
And everyone's like now. On our server, we had 3 drivers failed within like 2 months, and half of everyone's data was lost.
Maybe you should back up your data.
That is our backup.
As many
The
openings as you want.
admin.
But if you're happy with
What?
just
If
3
I run like you
those,
said, just the tilde bin stuff, and then they say permission denied, what does that mean?
Tilde bin?
Yeah, all this,
Did you write it right?
yeah. If permission denied, what does that mean?
That means that your user can't look at it.
Oh,
So you
as many orbitals as
you did tilde bin new log ban before pan.
is class code.
wait, eh? Oh. Well, no mind, I think I got it.
it's fine,
This-
then you plug it.
This thing is in here.
Well,
I'll have to modify it,
Right.
right?
automatic, yeah, it is different, but you can just download and plot with Excel, or just do.
Okay, I really need to start working because I haven't not looked up.
First band.
Jabba, are you getting worried?
I'm enjoying this time. See you.
Make sense?
Yep.
Can I watch, or is it a secret?
No, we're just talking about the election again.
Okay. Not everything.
Well, I think I need a copy and postcard, all that stuff I just got. Yeah.
No, just copy. One. Sweet. It was not correct. there is a whole bit. Here's word done. No. Need to modify. You watching and understanding what I'm doing.
Yeah.
You don't need. So we need only. Well, first, if it was for me, it was 6 column. I wasn't showing, but in this list of ascribed. Why number 4 versus number 6?
The money sign tells Arc what column to read. So if you say print money sign 1, it will print the first column. If you say money sign 2, second column. If you want to print multiple columns, you just do money sign 1, money sign 2, and if you want spaces between them, you put quotations. Does that make sense?
Not
Kind of.
So if we do this command manually, the basic
Did I ever get with the
Yes,
space?
yes,
Okay.
yes. See, I'm doing more out hard. And just manually through. So we are coming to several lists of energies. And this data is, we just want to put them on columns. We need to extract.
So Black Friday is coming next. Let's get a new one.
Okay.
Comp
No,
1,
it works. I don't know.
4, 5, 6.
I
So
don't,
the third component is
because I don't
actually
have enough
6.
carbon.
Mine, well, I gotta look here.
The third component of the vector is the 6th column in this program.
Okay.
Then we need to drop number orbital to pull this
Okay.
the script. Now we,
I don't know what it means, but yeah.
yeah, I think it is done. So here will be the value of k vector.
What's KO, Craig?
This one is here.
Something of acceleration.
And here are the values of energies ordered to the
Right here,
They should go back to your thing.
If you look for the force length, first
Have.
this
Show the
should
car
be
one.
minus nt for minus. Okay. And then when it prints
It makes an
this
outcome
versus
one.
this,
Oh,
this
you're
versus
making it.
this, and this.
Yeah, see, when
Call
you
it.
run fast, it should make an outcome one.
No. Makes an outcar. I don't have
You
an
just
outcar one.
pull this way, and you just very similar to this one.
Okay.
Just try to pull file.
Here, this is, so I just ran my script. And
What's the outcar one?
That's in the header, in the file.
I have modified the script and edited it, so it is if we reduce outcar only to those segments that contain our band energy, because there is so many
Yes.
garbage.
Yes.
So just and I was doing like grep key points,
Mm-hmm.
grep minus A15 key points, outcar into outcar 1. So it takes the keyword key points and adds the key ones after.
Oh, I see.
So,
I
because
see.
otherwise it's 3,000 lines.
Okay. That works.
Everyone is happy? To some extent. And you see there is a development of these records that witness several self-consistency cycles, because we are doing DFT procedure. And the type of exchange correlation functional is stored in the podcar file. This one that we are using is optimized for so-called PB function, Purdue-Burke-Erzakov. If you develop results for your project and your colleagues or referees will ask this which functional, you can answer PB. So if it doesn't achieve convergence until 60, cycle number 60, it will stop anyway, but hopefully it will converge before that. So we spent about a couple of minutes and it went through 16 steps. So it's maybe 8-10 minutes total to complete this job.
Quick question. Trying to copy that directory.
Minus R.
See, the record with
Minus
R
R.
did disappear, so there is a chance that
Minus R means
it has already completed.
So if you just have the type, like the directory name, it only copies that level. But you want to copy everything under it,
So,
so you have to copy it recursively.
if we are looking to OSICAR, which is just
So that-
monitoring of the self-consistency steps,
Where you're adding everything.
you see that it
So I
shows
think
the
R sync
final total energy
minus A
and it shows the magnetization.
is R sync.
When we were dealing with open shell models,
if you
magnetization
copy
was
directly,
always
that's
zero
fine.
because they are not magnetic. And if this is bigger than zero, it means that there are some
you asked?
unpaired spins. So let's do the simple exercise of looking through our car file. I will scroll through until I see something interesting and then I will go around and see that everyone comes to this point. So if you want to repeat it, just copy input files from this directory to your subdirectory, run wasp and see the data. So if you are going through outcar file, we see this iteration, which is self-consistency cycle iteration, and there was about 20 of those. As soon as they are finished, we do see record for Fermi energy, and then list of orbitals. So you see the record k point 1, and there is only one k point. We intentionally requested only one, but there is additional record that we haven't seen before, spin component 1. And we are scrolling through, see number of orbital, energy of orbital, and occupation. Before it was 2 or 0, now it is 1. So we are scrolling and making an observation that for spin component 1, the orbital number 25 is occupied and number 26 is unoccupied. Right? 25, 26. If we keep scrolling further, we see spin component 2. There's a list of orbitals, and you see something is different. Now for spin component 2, for spin down, the HOMO is 24 and LUMO is 25. So the number of highest occupied orbital depends on spin component. And the difference in these two numbers is the spin polarization parameter. So it means that there are one more electron with spin up than number of electrons with spin down. Good. So I'm going to circle around and see if you came to the stage, and then we'll go further with generating the density states. By the way, there is an opportunity to plot orbitals, and they same as we did for those, and they will look different for alpha and beta. So one needs to plot two sets of orbitals, alpha and beta. I think we did it in Gaussian. Alpha, A, MO, B, MO. And there is an opportunity to do the same with VASP software.
Oh, I'm good.
Good.
Yeah.
So you have these files.
Yeah.
Good. You got them.
But the values, is at 25 and 26.
Yes.
I use the same file, that is set 25, 26, and then one is 27, 28.
You didn't change the oxidation state.
Just the number of electron change, right?
Yes.
So,
So
49.
there are two
I did
heavily yes, but you need to remove this percent in front.
oh, okay.
This symbol means that do not look on this record.
Oh, hashtag means do not look.
Yeah.
Oh, okay. Thank you.
I forgot to change the oxidation state too.
Spin equals 3. You are a candidate for Nobel Prize. If you find a mode electron spins through.
Remember how to copy things. I like sort of remember, yeah.
A little comment, as you will start doing your projects very soon, I know that we all are targeting big science, we have scientific curiosity, but practically, very important thing, name your directories appropriately.
What?
If you're running several configurations, like different oxidation states, do at the same level of directory tree, repeat the name of the compound and just add 2 plus 3 plus 4 plus. If you change spin configuration, just add singlet, triplet, because if you do it as you like, but develop your own system that you can navigate through. It's the easiest thing to get lost in your own directories. So see, it's like levels.
Yeah.
One level up.
But do we have to change the number of electrons too?
Whatever you want to
Just-
change it to.
And then
Do you want it triplet?
You can
I mean, do you want it to be,
For the plus 3.
then you
shows everything with
3 electrons away from the number of electrons, which I
And then you
believe is
tap and it automatically
2.
See, I was trying to do that.
Well, I have on this, the in-car for him is 55
Please.
now. The copies that already changed the 52 originals, but he added 3 and 4.
Okay.
Okay.
But then
And then
Then that would be a
it was already
3
completed.
minus.
You just look.
Yeah, 3 electrons.
This one.
Or, that's what he did.
Okay.
So, there might have been,
And then you see same.
oh, yeah, so
what
the
did you do
ha-
to change
hashtag
the
number of
oxidation state? That
electrons,
was the one.
I'm assuming that needs to be, like,
29.
yeah, because this might have been, he just copied it from another directory,
Oh, okay.
so,
Okay.
I just this is we wrote how many electrons I want to be to set. This model. Okay.
For now, I think, yeah.
You're just gonna change the electron.
49 and remove hashtag in front.
It was like written like this.
Yeah.
So it's 14.
And then you can do it the second line.
So what do you need to find?
So if I just left the hashtag there and then
It
change
it reads if you have several versions of the same command in different numbers, if you take the
Oh, it will?
yes, if you have those with hashtag, will be skipped.
Okay.
And how do I get out of this?
Escape or quit if you do not want to save, and right quit if you want to save.
Okay.
Good. Okay. So your home is 25 for up.
I'm running it again because I didn't join this pin actually, so I didn't
If we take open shell model and forget to put iSpin, it will be not trustable results qualitatively. It's not just getting half electron volt less or more precise. It will be wrong in principle. So if you predominantly know that it is a magnetic system, you can not skip iSpin equals to. Good. How are you?
Yeah.
Good.
Oh, I'm at this step.
Uh-huh. So if you do not, you want your scientific career, you have some curiosity, but you are limited in time and you need to show productivity, and you do not target for like top journals. For the applied research on magnetic materials, it is sufficient just to scan through several configurations and report those density of states and just write your observations. Because in this area it is not super demanding. If you want to guarantee, like guaranteed minimum, you artificially set up high spin and low spin, compute total energy, subtract them from each other, and then tell, okay, it is the energy of magnetic ordering. So one can get to competitive level relatively quick. So everyone got to these numbers. So we are going to visualize them. The idea is that we need to extract these segments of data and then just process them in the same way as we did for closed shell density of states. Just a little reminder, I don't know if you care about it, but so when it assumes that at each energy there is a little peak, and has several peaks, then it converges into continuous line for density of states, right? So instead of delta function, one is using Gaussian overrides and with fixed width, where fixed width is determined by the temperature. If we do have two energies, E up and E down, we can do N up, energy up, and if you do have density of spin down, then we do the same, but just put here epsilon sub I comma down, or alpha and beta, and then we can draw it as pictures projected upwards and downwards. So we will be just doing the same in a practical sense. So what's the total number of orbitals here? 44. Okay. So we need pair of states, pair of files that will be named states up and states down, right? And we can just manually parse them out of the outcar. Just copy pasting or doing grep band energy, grep minus a so many band energy to take whatever is following this line. Or you can run this little code, extract energy, which you should create this energy pop and energy pop down. So I'm telling more states up, and then it has a list of all orbitals, their energies and their occupations, and more states down. So given a list of orbitals, their energies and occupations. So just in case, here is the service file that contains first orbitals that we need, last orbitals that we need, and service number 1. So if you do not want so many orbitals, we can look of just couple of orbitals near HOMO and LUMO. And here is the name of the command to save your effort and not doing hard manual labor of putting numbers out of the big file. So I'm going to walk around and see if you have these two files, states up and states down.
Question, so for input overlap, you make the file?
Yes, you just.
Okay, you just make the
Mhm.
file itself, and then to make states up, you copy the energy out.
Mhm.
States down,
No,
same thing?
no, no.
How do you do states down?
I have no idea. 49.
Wait, you didn't run.
49 is
Run what
go up and down, right?
Yeah.
Also extract energy
Put
from.
that down.
Oh, yeah, I did.
Oh, yes,
Right.
yes.
I
yes,
did,
yes.
so I copied.
Or whatever
and
the
make states
keyword
up.
is.
Yeah,
Okay,
that's
good.
49.
49.
And then how do I
And then you say I smear equals 2.
No, no, in
Oh, okay.
49,
Oh, okay,
that
that's for down.
clause
Okay.
is asking for the electrons simulations.
I am writing my own script because I don't want to deal with any of that crap.
I need to put that one.
And then on 0.
Fine.
Well, they contain relevant information in it.
So I went into the input over.
I will insert.
So I copy energy up down into states.
Colon, right click.
I feel like we're becoming Brenda because if you read a script to save him like 10 seconds, but it would take like 10 minutes to write. But I don't want to type in all those things every time.
Yeah.
Okay.
Okay, it's not that
Thank you.
bad, but
Okay. And I missed some stuff you did after that, but.
Then just see the last line.
Oh,
there.
that's it?
Mhm.
Oh,
Pauline?
Got my states up and down.
Good.
I made the, so this is the stuff I copied from yours, I made the states up and down.
Mhm.
The more overlap.
Mhm.
Overlap, we had
I,
148.
from the number of bands, number of orbitals is automatically established by VASCAD each run,
Okay.
independently, and from run to run they can be different. There are some numerical criteria to select. So we need to look for the actual number of orbitals.
Okay.
I will be back if I need to tell something to you. Type something. What is NBA?
NBA.
Yes.
Then skip oil. Maybe.
So grep NBA out card.
Association.
What are we expecting to get?
Rub bands.
Yes. If you do not want to go into the file and count orbitals line by line, we can number of bands and did you get this? you're going forward to the steps.
I got it before the one.
Okay.
What's the number of electronics supposed to be half of days or 40?
49. Yes.
But in one.
Typically, this error appears if the inconsistency with 44 and actual.
Your call will be disconnected.
It's file name is the file. Yeah, yes, file name.
Okay. State up.
Name is yes,
Just
states.
Just
Yeah, that's the one. Thank you.
Oh,
good. We have a figure.
I don't have this one yet, but that's my figure, that's story. I just had to times it by negative, flip it down,
How are we going to do it?
just in my Python script, times -1 times the value, instead of
There's more elegant way.
in
In
Uplot.
Uplot,
Oh.
you can do U13 multiply.
Like at this,
Yes.
-1.
Yeah. Well, you need to look for the manual for exact syntaxes.
But I can easily write it into my Python script, because I just go run.
Okay.
Avaya. Please enter your. The conference is now starting. You are the first person to arrive. You will now be placed into the conference.
But yeah, that's.
Really, the only process component is so good. Like,
So,
I don't know.
I
that
probably
sounds-
need
that's
to
all I
rush
know.
because you're ahead of me. Keep doing this.
No worries, no worries. I'll be here for a while.
Okay, thank you. Thank you. Binary,
Dang it, now that's gonna be in my head.
rest, this.
No.
So, I'm just following this manual and repeating same steps as we do for plotting density of states for alpha and beta components, for up and down. So, typing this tilde binary request dot up, number of states 44, minimal energy, maximal energy. We can quickly look and see that the interesting activity is from -8 to -4, so probably it will be not wrong to explore it from -10 to 1. For the Fermi, if I didn't make arrangements, I probably should stop. Oh no, I shouldn't. I already grab Fermi car. Okay, now I have the value of Fermi energy and I'm doing this dress DOS. Number of states 44, minimal energy -10, maximum energy 1. Fermi energy I'm copying what is extracted from the file. Alpha plus beta size, thermal width 0.1, magnitude 1, number of atoms something like 19.
Mm-hmm.
Makes sense. Number of electrons 49. Gap of titanium. Well, it doesn't change anything. Like 3. Dose up is written. Now I am enjoying to see that there are new files developed. Dose up norm, and then I'm repeating the same steps for the down. So the continuous line is saved in the dose up norm. Number of states 44, minimal minus 10, maximal 1. Fermi, I'm scrolling a little bit back and repeating these numbers for Fermi and for alpha plus beta. Width of line 0.1 is a good 1. Number 19, electrons 49, 3. And now there are files for up and for files for down. And after that, we want to plot them together. So the code does up down, a set of commands for graphical plotting, and you see that it plots DOS up and DOS down, but each of them is plotted 2 times. One with color, another without color. So we plotting the occupied and unoccupied lines separately, just to indicate what is occupied. So WI means with impulse, WL means with line. So GNU plot, this one. Then we are looking into the directory and see that we have developed new file dos up down.ps. If you want to convert ps to pdf, now we may want to copy this file to local computer. The name of the course here, the name of the individual directory, then the name of the compound. And just copying all files named with extension PDF into here. Now I need to find this file in the browser. Okay, so here is what we get and what you may get. So we are not interested in too many occupied orbitals and too many unoccupied because we do not play with more than ultraviolet light in our regular life unless we do X-ray detectors. And then you see that most of orbitals are symmetric. For alpha and beta orbitals, we have the same pattern here and there. And from our, if we would have more time, we should draw orbitals, plot orbitals for this system, which is not as difficult, but we better focus on absorption spectra, and then if someone wants to stay here, we can do orbitals, but it's secondary. But if we do them, we will identify that those occupied orbitals will reside on the oxygen from water in this hexa-aqua complex. And those 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 will be residing on the titanium. Those are 5 d orbitals on titanium. Typically, if it is, if you have 4+, then all titanium d orbitals are unoccupied, empty. That is empty. But here, this complex is mostly stable in the 3+ configuration, which means we have forgotten to remove one electron from the titanium d orbital. So it is here. And if we would prepare this complex in 4+ situation, then titanium d orbitals will be symmetric again. But as soon as we change occupation, it, like heavy, it pulls all orbitals down and symmetry is violated. So the pattern of orbitals is not as nice as it should be originally. What else? Symmetry inorganic experts present in class can suggest that in well, we can plot the orbital. You will see that octahedral. In octahedral coordination, the d orbitals exhibit two EG orbitals up, 3 T, 2G orbitals down. 1, 2, 3. So this a little higher peak corresponds to degenerate orbitals. So those are 3 T to G orbitals, and these are EG. And they both are available, both types of, and here is the octahedral splitting, which is about 2 eV here. So probably, well, it will be optically active. It should, the titanium 3+, what it is in experiment, if you adjust it. Titanium chloride in water should be something like, I don't know, purple.
I don't know.
But one can look online. I have a big suspicion that this compound will be colored. And this splitting, octahedral splitting, determines the color. If you change water to ammonia, this splitting will be different. Here are also this T to G and EG, but they got corrupted because it is not absolute symmetry. There is influence from this electron, but those will be EG, and this 2 and this one will be from T to G. It is very pleasant way to spend your vacations or weekends. Just plot orbitals and find correspondence between your expectations, especially if you do it not for the class but for the research. Like if your research is dealing with metal organic complexes, it is what you are expecting. It is what you are expecting to do. Please try to generate this plot, and we will continue in a second.
Big problem would be splitting to Young-Teller dispersion. Or would that not be included here?
Yeah,
It's D1. I don't know if D1 has Young-Teller.
why not?
I don't remember.
It's octahedral. It hates being high symmetry.
It hates being octahedral because that's not the lowest energy geometry.
Especially not since you have only one electron in there. So if you wanted to calculate your octahedral splitting, would you use the alpha side?
Well, that's the one that's popular, so that's the
No.
transition.
I don't, well, I don't know.
Okay, alright.
But I don't know which one is more. But the order between lowest of these three and highest of these three here and there is not as much different. And maybe, well, from the symmetry theory, there should be reasons to go away from this ideal octahedral.
Yes.
Yeah.
Jan Telner,
Yeah.
That's what we just talked about.
If one goes to absolutely symmetric lattice, if one takes cubic lattice of some other mineral and replaces metal like lead selenide and replace lead to titanium, then probably the splitting will be much more ideal, because these water molecules have degree of freedom to move around, and those hydrogens are also facing different directions, and they may provide additional energy like mine. So we are quickly moving to research rather than academic learning, because the semester is short. But if you would stay here if the course will be year long, here will be a right time for homework on plotting orbitals and repeating this calculation with different number of electrons, and see which number of electrons provides smaller total energy. So find most stable compound, most stable oxidation state. Another exercise that would be naturally connected to it, that we just will probably skip for now, is a keyword n up down. Right now we didn't set up this keyword. Okay, -1 means take whatever would be most favorable according to point of view of the software. But one can manually change this keyword n up down, and it means number of electrons up minus number of electrons down. So right now we have this difference equals 1, which corresponds to a doublet. For this system with odd number of electrons, we cannot go to triplet, but we can go to quadruplet. So if we set n up down equals how many? So 0 singlet, 1 doublet, 2 triplet, 3 quadruplet. So if you put 3, it will mean that 1 electron will be removed from this oxygen orbital and placed to one of these titanium orbitals. And then total difference of alpha and beta electrons will be 26 minus 23, right? So the energy of highest occupied up was 25, highest occupied down was 24, and if we will change them by 1, it will be 26 and 23, and their difference will be 3. So one can go from doublet to quadruplet just by this number. If we are starting with singlet, one can go to triplet by setting n up down equals 2. Make sense? Most likely we will have no time to have fun with these keywords, but some of you may need to play it in your research projects. So if your material is potentially magnetic, or it is metal cluster that has unknown number of oxidation state and a known number of magnetic polarization, one may scroll through different values and find which one minimizes total energy. It would be a very natural direction of research for any metal-organic complex or metal particle. Spectra.
I don't like how this is sounding. It's quite a lot of writing. I don't like this. This is getting, a lot of this just let it work.
So same as for density of states, and everyone got the picture with density of states, right? No? Give me secret science if you didn't. Okay, I'll quickly go around, but I'll bring something to the screen so that you can go this
Hey, Sam,
spectrum.
go to your command line. Make a new directory and copy your outcoding. Oh, you got kicked off. So are you in the directory where you had the spin polarized calculation? Okay, can you copy that? Can you make a new directory? Copy your out car into that new directory. Go to that directory and type in capital, everything's capital, D-O-O.
Okay, wait.
So here is the command that you just need to type for alpha projection and then same one for beta projection.
Then something. Okay. Then go into something. So C.
Okay, what is your little menu?
Okay, now just type in capital dots. Try and tab. Okay, push enter. Oh. Okay, you can remove that directory. I was seeing if the script I wrote works for you, but apparently it doesn't.
Shoot.
I don't know why though, and I don't care.
you don't wanna debug it? Can't remove that directory. How do you remove the directory?
Recursively. Minus R. That's also if you want to copy a directory.
Instead of RM minus R?
RM.
But remove is what I use to like delete a file, like the R remove the
Oh, okay. So RM space minus R, the directory. That's weird.
What's the minus? You're recursively reading? So anything like inside of it you're removing as well?
Yeah. So like if you think about the family tree again,
Yeah.
if you like disown your brother's family, you disown him, his kids, their kids, everything. So you never want to go into the main directory and say rm minus r star. Never, ever, ever,
Don't say that,
ever,
now I'll have,
never do
you know,
that.
you said that,
What
now.
was that command again?
Yeah, that's, I'm gonna be saying, I think Levi told me to do this at one zone, at some
No.
point.
Let's just say if that happens, there's gonna be some fire and brimstone, because Dimitri's gonna bring it down on someone.
Never do what?
Never,
Delete everything.
yeah, never delete everything, never.
No, just take this one.
I don't even know the command to delete everything.
That's why I'm not saying it. Like,
Yeah, because
No, that's
he
probably a
told me,
good
so
thing,
now
because I
I'm gonna be
probably
sitting there.
accidentally do it.
I think you told me this is the command to do.
no,
Wait, delete our own file or delete,
no, delete everything,
How,
oh, his stuff?
everything
Oh,
in his directory.
but we can delete our own stuff, right?
Yeah, yeah, but that's your stuff.
Okay,
He doesn't care about that, he really can't.
so I say I have
So you're getting
I have
web to work.
my folder here and folders down here, and I wanna put all these ones into another folder here.
You just.
You mean
copy it.
halfway down on the first page?
Replace it.
Folded?
Yeah,
Yeah, no,
Make
I'm
a
working on
directory,
that.
move everything.
let me know if you have
But
some.
why would you wanna move everything into a new directory?
So I had my son, and then I have all this other stuff that we've been practicing. So-
Where's that?
So I got stuck all the way back here.
So,
So I did all that, but I got an error.
You didn't do all of these calculations in your,
no, I did.
oh. What are we waiting
So all these folders that we've been kinda using for practice, these are like the,
for? It's still in, oh, so
Yeah, this is
you
all-
wanna clean this directory?
yeah, so if I wanted to put all these in different,
Yeah, you just make it new one.
There's
in
empty.
the, are recursive, or just in these ones, right?
I don't know, maybe you don't have to do test. You might not actually have to do it. No, you don't have to do it, moving to directories apparently.
No, well, I didn't get an error, but it's not
If
copying.
you have a
There's nothing
problem,
in it.
There's nothing.
just
No.
try minus R.
Okay.
Oh, if I did that. Because I think what it's doing is it's trying to grab these lines. Unless we're supposed to indicate the number of lines.
Now, don't get me sick.
I'm not sick. Perfectly healthy as always.
Your voice does not sound that way.
No. Good to go.
Like a burrito from Taco Bell, good too.
Yeah. Forgot about that.
I
I haven't had Taco Bell in a long time.
haven't either.
Okay, and then for this part.
Oh, it was like the
I
big
just
thing.
started.
Oh, okay, so you
And I
just
don't
type in
understand
what you
why
have
it
there in
works.
the
Yes.
middle.
Ice cream.
How are we doing with spectra? Anyone progresses
Oh,
forward?
We're trying to do
This
this now.
grep is not working for me. Not
Grep?
me. Yeah.
double space.
Okay, I will go to the grep.
Oh,
That's what I
okay.
Oh, you already helped?
Yep.
Okay.
think so.
So, home, binary spin, os dipole spin up, and then the same put down. So as soon as you do have energy pop files and input overlap, they will run. So it is a demonstration of healthy development. Now, there is two sets of file: oscillator strengths, which will be oscillator strengths for alpha electron, for up, and oscillator strengths down, for beta electron, for down. If you look through them, more oscillator strengths. I'm just checking if there is a recording going on. So I'm looking for this oscillator strengths file, and you recognize the format as same as in your homework. So pairs of orbitals, oscillator strengths. The last three are three components of transition dipole, energy of transition, and occupation numbers. In comparison to what we had before we had always transition dipole from occupied to unoccupied. We had always 2 here and 0 here. Because if we perturb ground state of the system with light, it can go only from occupied to unoccupied. But if the system is in highly non-equilibrium, then it can go between any pairs of orbitals. Therefore, this format saves any pair. Like if you need photoluminescence from, then you can get your LUMO occupied, and it can give transition to HOMO, or it can go to second order absorption from LUMO higher up. Therefore, this additional information is stored. But if we just need linear absorption, we need to parse only those records that will go from occupied to unoccupied. So it is what was this grep command. And you notice that here numbers are 1 and 0 instead of 2 and 0. So we are looking that there are almost no transitions of the type that we are looking for. Most of them are from 0 to 0, from 1 to 1, inside band. But here I see an example from occupied to unoccupied. I'm copying it from 1 to 0 and do grep this pattern oscillator strength into service file that I need just for a short time. So this file will be much smaller, and if I'm looking more was up, then you see that all transitions are from occupied to unoccupied. And if you look for the length of the file, it will be like 4 times shorter, approximately. So it is what we need for linear absorption. Now we need to do the same thing for the spin down component. So we parse lines that do have transition from occupied to unoccupied for the down for the second component of oscillator strength, and bring it to a new file. Just for curiosity, we see that files do not look of a big coincidence. So the transition energies are a little different coming up, and the values of transition dipole are a little different because this additional electron in the conduction band among the orbitals that are typically unoccupied spoils the pattern of absorption. Okay, now there is a shortcut. Like if we are tired and want to go home and go to preparation of our things, And then we do not care which electron is getting excited, spin up or spin down. So we can just fuse these two files together and process it as we did regularly. So it will be like necessary minimum for all of us. We will do it, and then those of us who are in a rush can leave. And those of us who are enthusiastic to do a little more, we can separately plot spectra built out of the alpha and beta component and see which of the components contribute more to the absorption spectrum. Experimentally, it is not as easy. It's probably need to placing the sample in the magnetic field to separate this alpha and beta component. But here we can do things that are not easy for experiment. So fusing together these two files. So we have os down, os up. We can do concatenate os up bigger. Before we do it, I want to remove or move oscillator strengths into os strings up, so that now we do not have file oscillator strengths. No such file directory. So we will use this service file, this standard file name later for building the spectrum. So we do cut os up into oscillator strengths. Cut os down into oscillator strengths. WC oscillator strengths. To know how many files, how many transitions. So from this point, we can deal with it as we did before, as we did for spin non-polarized, for singlets. Just take this file and process it by converting set of elementary transitions into continuous line, right? Let's see that we can do it, and next step could be either go home or try doing separate partial contributions from alpha and beta. So we know how many orbitals, and now we do just standard beam spectrum improved version 3. Number of transitions. I'm just copy pasting this 955. Setting up the range I want to look at. Width, number of HOMO. I don't know.
So is that just arbitrary then, that number?
In the previous versions of the codes, it was looking from all orbitals below a given number to all above this number, and in the latest version, if it was not lost, at least I was manually changing it, if it was not corrupt because of everyone has access. It takes transitions from orbitals that have tag occupied to those that have tag unoccupied, independent of what HOMO and LUMO are.
So it doesn't matter.
It shouldn't matter. So what do we have? We have file spectrum. Just in case we will do partial contributions, we can make copy of this spectrum into spectrum complete. There is a chance to plot all three: contribution from alpha, contribution from beta, and a contribution from both of them. But if you do not care about it, we do just standard plot. Ah, wait. If you hate GNU plot, you just take this file and plot columns. First column wavelengths. First and second and fourth are transition energies, and the third one is intensity of the spectrum. But if you like GNU plot, then you type GNU plot tilde binary GNU prog SPE if you are fine with electron volts. And if you are not fine with electron volts, you type SPE nanometers. And PS2P, right, spectrum PS, and spectrum nanometer PS. So LS minus LT. So here is the list of new files, and I can go and download all files with extension PDF to the local computer, and then look in them. Open. So, even if we do not resolve it by spin components, we see that there is a transition a little above 3 eV, which corresponds to titanium dioxide and structures of titanium dioxide. So it is natural from O to P to T 3D, titanium 3D orbitals as target, and source as oxygen 2P orbitals. So this would be also in our homeworks for titanium OH4, where the titanium was in 4+ configuration. Spectrum, and this is transition D to D. Maybe the intensity is a little off, but in principle, in such configuration, there should be this transition between these D orbitals. So this one will be alpha, and this tail will be both synergy of alpha and beta components. So by now you have minimum practical skills to go to research. If your schedule is tight, if you are rushing to prepare your tomorrow presentation, I do not object to going home. But I'm just curious myself to look how it will look for the partial contributions of alpha and beta components to this spectrum. So now I am removing oscillator strengths file, and I'm just copying the os up into os strengths. So I will look only for contribution from alpha electron up. Now inspecting the number of the transitions, 475, reasonable. And now I'm running the same code for converting discrete set of transitions into continuous spectrum. So this code is looking in the directory for a file named os strengths, no matter who created and what is contained. Now we feed in only alpha transitions into this os strengths. You see here it is CP os up into oscillator strengths. Now we run this one and answer a couple of these silly questions. 475 transitions, looking for the whole range with 0.1 width. Whatever. And now there is a file spectrum. We can call it to the more generic, from this generic name to spectrum up. you can call it CP spectrum into spectrum underscore up. And later we will plot three spectra, up, down, and complete. So now we have three components, we have some of them, and we need the down component. Now I'm going to remove oscillator strengths and feed in the down component, CP oscillator strengths down into oscillator strengths. WC os strengths, checking how many lines are in this file. 480, so it's a little different. 5 transitions more. And I'm running the same generic code that converts discrete list of transitions and their oscillator strengths into continuous spectrum. So 480 lines in the window from 0.1 to 10, line width 0.1. And now I'm copying the spectrum into spectrum down. So we expected to have three files: spectrum up, spectrum down, and spectrum complete. With spectrum complete being just algebraic sum of these two files for their spectra.
Oh.
Right? Now we are going to just apply GNU plot to this script. GNU plot with these arguments. So this set of commands will be executed and it will generate the file sp_spin. And then we ps pd convert spin, convert into PDF, look that we have this file, and download it to the local computer. So as we discussed, and I promised that I didn't know what will appear. We were doing this model for the first time here. There are three lines: alpha component, beta component, and all together. So alpha red, beta green, all together blue. So the strong peak is D to D transition in alpha component, because we already have one electron among the titanium 3D. And the beta component has 0 at the optical range. Then in the UV range we have contributions from both alpha and beta, and we do not see contributions from alpha because they are hidden by the third line. But the overall summation of these lines comes together and to this blue one, and it has both contributions from infrared range and then UV range.
But how is your blue smaller than red?
Because it is 1/2 average. A plus B divided by 2. Whew. So we do not have time to plot orbitals. We should go and prepare. Well, from now on, next how many hours? Less than 24 hours. Our primary goal is to make presentations.
Try it.
And I would appreciate very much if you send your slides by midnight. I need a little time to process them together, arrange them in the printout so that each of us can look through them. And also, I will, before printing, I will look through, and if there are some strong mistakes, I will communicate and suggest changes. Any questions? What will be last educational thing? Very last. So, list of the directory tilde binary in car. Bigger font. So here there is an in-car partial charge spin. So if you want to plot orbitals for this model, you copy this template in-car into your directory, rename it as an in-car, and rerun VASP. And then you will get set of partial charge files that can be plotted. And each partial charge will have both alpha and beta components. There are some other stuff that we can go through while doing research. Like one can change functional, one can do different types of calculations, like one can do normal modes, analysis, and something else. But enough for today. Lab is finished. I look forward for any questions. I will stay tuned for emails or maybe even phone or Skype calls. But we are going off records, and please send PowerPoint slides before midnight to my email. Thank you.